Hello, good morning everyone. Today I'll be giving you a hints of those questions which I have sent you in the form of an assignment. Of course, it's an integration one, and initially I will be taking the one marker questions which will makes your concept as well as formula perfect. Now, first question is root sin x into cos x dx, of course. Now, if you put sin x is equal to t, you will get cos x dx is equal to dt, and the type of formula which we'll be using is integration of x to the power n dx, which is equal to x to the power n plus 1 upon n plus 1. Now, following this into the second question, which is dx upon 1 plus cos x. In these kind of questions, we just simplify this by multiplying numerator as well as denominator with 1 minus cos x. Now, once we multiply by 1 minus cos x numerator as well as denominator, it will become 1 minus cos x upon denominator, which is sin square x. Sin square has x has come from 1 minus cos square x, right? Now we have to simply 1 upon sin square x minus cos x upon sin square x. Now I hope direct formulas will be there of cosec square x and cosec x into cot x, or something like tan x into sec x. Direct formula will be there. In question number third, e to the power 2x minus 2 in the denominator, and numerator we have e to the power 2x. Now if you put e to the power 2x minus 2 is equal to t, you will get the right direction for solving this question. But don't forget that coefficient of x here is 2. Question number fourth, we have tan cube x into sec square x. Now simply if you put tan x is equal to t, you will get sec square x dx is equal to dt, and it will be of type t cube dt. So very first question is similar type, x to the power n dx integration, that will be done from that particular point of view. Now question number fifth, we have a sec square x under root 16 plus tan square x. Now it is a similar question of exercise 7.4 we have, where we have some standard formula of dx upon under root a square plus x square, dx upon under root a square minus x square, and dx upon x square minus a square. Now in question number fifth, if you put tan x is equal to t, you will get sec square x dx is equal to dt, and I hope you will be able to use the formula as well as the format of exercise 7.4. Moving on to question number 6, we have integration of sin 3x dx, and sin 3x integration is minus cos 3x, and since the coefficient is 3, we have to divide it by 3. In question number 7th, we have integration of cos square x dx. Forget about 0 to pi by 4. 0 to pi by 4 we have not taught you, it is by typographical error I say. Now this cos square x, you can easily do it something by using cos 2 theta formula. Cos 2 theta formula is cos square theta minus sin square theta, or it is 1 minus 2 sin square theta, and you have to rearrange the terms if there is a integration of sin square theta also. Now also for cos square x or cos square theta, we have cos 2 theta as 2 cos square theta minus 1. So once we talk about cos square theta, it will be from that particular formula will be 1 plus cos 2 theta by 2. I hope again you have to separate the numerator and proceed further. Now 8th question, we have 1 upon under root x plus x. Now take root x common, and it will be like 1 upon root x 1 plus root x. Simply put 1 plus root x is equal to t, job will be done. Now moving on to question number 9th, we have e to the power 5x plus 3 into dx, and as we know that integration or derivative of e to the power x is e to the power x. Now it is e to the power 5x plus 3, it is e to the power 5x plus 3, but coefficient again we have to divide it by 5. In question number 10th, again it realizes me with the format of exercise 7.4, some standard formulas of dx upon x square plus a square, or dx upon x square minus a square, or dx upon a square minus x square. So if you put x to the power 4 is equal to t, you will find the path. Students, do give me the feedback whether you are able to understand it or not. If you are not able to understand, which I don't think so, there is a possibility, I'll modify my teaching, right? Thanks a lot.